Hello, everyone. I'm Gemma Roig. I'm a postdoc at Poggio Lab at CBMM. So we work on computational models for object recognition. And in particular, we work with the hypothesis that the first 100 milliseconds of computations in the primary visual cortex can be modeled with a hierarchical feed-forward network. And this is because there is not enough time for feedback to take place. So in particular, one of the things we are interested in capturing in our model is the visual acuity that is dependent on eccentricity. So as you can see in the picture, where we fixate, we have very high resolution of the image or the scene that we are looking at. And at the periphery, this resolution is much lower. And this is mainly for this acuity dependence in the retina. So how can we model that? So we use a model that has this kind of shape that is an inverted pyramid. And mainly what it does is, given an image, it crops the image at several resolutions. In the higher resolutions, we have like where we fixate like the smaller crop, and this is with a high frequency spatial resolution. And at the highest scale, we have lower resolution. And a particularity of this model is that the number of units at each of these scales is the same. And why is that? It's because we aim at having invariant representations, specifically in this case, in scale and in certain positions, and having the same amount of units at different scales will allow us to have invariant scale. So here you can see how the image looked like at different crops, and on the other side you can see how the model perceived the image. So you can see that at the higher scale, the image is perceived at much lower resolution, and you cannot distinguish the object that in this case is a 3. So with this kind of inverted pyramid, we built hierarchical models, and we learned those models with backpropagation. And this is quite novel because until now it was believed, or we had the assumption, that backpropagation cannot learn or cannot be used for learning because we need a lot of examples with labeled data, and this is not how humans learn the representations. But now we have this assumption that we can maybe have the labels with what we call implicit learning. Like with videos, we know which objects are the same, so we are using backpropagation for that. And then for acquiring and having this invariant representation, then we pull over different positions of the model and over different scales. So we have some results that I can show you later in the poster, in which we obtain these invariant representations to position to a certain extent. And we have the hypothesis that such model will be much robust to clutter, and this is where we want to go in the future to check this robustness. Thank you.